Let us discuss this example. So in this example, we have to find an open ball, okay? But the metric is little bit different. So what is the metric they have mentioned? You can easily see here. This is delta of xy. So that metric we have to follow and we have to find out the open ball in R2 since this is example of R2. Okay, so let us follow the definition and try to solve this problem. Okay, what we have to find? See, I will simply write by definition. We will follow the definition. So B, this is an open ball with center origin 0 0 and radius is R. So 0 0 and R. See, you remember not the definition of open ball. The definition says, so xy belongs to R2, xy belongs to R2 such that distance between, just a minute, So instead of D, we have to take delta since metric is delta. Delta of xy comma 0 0, that means distance of xy from 0 0 should be less than R. Okay, should be less than R. So simply I use the definition and I wrote this one. So this is equal to, let us continue. So xy belongs to R2. Okay, so definition of delta says x and y. So this is our x and this is our y. You are getting first point, second point. So definition says delta of xy is equal to norm x plus norm y. So let us follow the definition. That means norm xy plus norm 0 0 less than R. Okay, so this is equal to, I will simply copy xy belongs to R2, xy belongs to R2 such that, see, norm is Euclidean norm, it's regular definition. You know the definition of norm, square root of first plus square of second. So by following that definition, I can write square root of x square plus y square. So here we have to follow the same definition. So square root of 0 plus 0. So simply I can write 0. So this is less than R. Okay. So this is equal to, I will rewrite the same thing. xy belongs to R2 such that, see, 0 plus this one you will have same, square root of x square plus y square less than R. To remove square root, I will take square of both sides. Let us remove square root. Okay, so yeah, let me write xy belongs to R2 such that x square plus y square less than R square. See, actually, if equal to R square is there, it is an equation of circle with center origin and radius R. But here we have less than. So that's why it's the interior part of circle. Getting the point? So clearly, if there is less than, interior, if there is equality, boundary, and if there is greater than, exterior part of circle. Okay, so here we have interior part of circle. So I will mention. So therefore, it is an interior part of circle with center what is its center? Center is 0 0 and what will be its radius? Radius R. So I will show it here. So this is a y axis, x axis. Okay, suppose R is here, R minus R, getting R minus R, here R and minus R. So it is a circle, okay, which passes through these 4 points having radius R. Okay, so actually I am drawing that circle by dotted line because it does not contain its boundary. Strictly less than is there, that means just interior part of circle. When we have equality, that time we have to consider a boundary. So it is a interior part of circle. So I will show in this way. Okay, so this is the interior part of circle, right? Okay, so we got circle, that's it. See, one more problem we are going to solve, okay, which is same as this one. But before that, I suggest you to take a screenshot of it, and after that we'll go for second problem. Okay, so let us discuss second problem, which is same as previous problem. The difference is here we have to find this ball BXR. Getting BXR, this ball we have to consider, and where x is not equal to 0 0 and it is looking different. Norm x is equal to epsilon they have mentioned, and 0 less than x less than epsilon less than R. So let us follow the definition. Okay, no need to think much about it, just follow the definition and let us find what will we have. See, I consider the definition, so I will simply mention by definition. Okay, so that this is B X R. So the definition of this ball says Y belongs to R2. Actually, this is in element of R2. So that means when I write X now, so that X should be in this form, X1 comma X2. And when I write Y, so this is element of R2. So that's why it will be like this, getting Y1 comma Y2. Okay. So let us continue. Just a minute. I will remove it. It is not required now. That was only for understanding. Yeah, so definition says delta, since we have a delta of xy less than r. So this is by definition of open ball. So this is equal to y belongs to r2 such that delta. Okay, so delta, definition of delta is this one. So this is norm x plus norm y less than r. Agree with me? So this is equal to, see, y means basically, as I told you earlier, y1 comma y2, since it is element of r2. Okay, such that, see, norm x, they have given something, value of norm x is epsilon, so therefore epsilon plus norm y means y1 comma y2 less than r. Okay, so this is equal to y1 comma y2 belongs to R2 such that, what will I do? I will shift epsilon on that side. And you know the definition of norm. So it is square root of y1 square plus y2 square less than r minus epsilon. Right, since I shifted epsilon on that side. So to remove square root, what I need to do? I will take square of both sides. Okay, so let us take square of both sides. So this is y1 comma y2 belongs to R2 such that y1 square plus y2 square less than r minus epsilon square. Okay, so see, if equality is there, so it is equation of circle, right? If equal, if you consider equal there, so equation of circle with center, origin and radius r minus epsilon, but here we have less than, so that's why it is a interior part of a circle. Okay, so I will mention that thing here. So it is an interior part of circle. It is an interior part of circle. What is the center? With center, I will mention center is, it's a standard circle, getting, so center is 0 0, and what will be its radius? Its radius is, see, r minus epsilon square, no? So radius is r minus epsilon. Okay, so that means if I draw circle, it will be like this. So this is x-axis, right? This one is y-axis. Okay, so r minus epsilon, suppose here r minus epsilon 0, and this side also we will have minus r minus epsilon here also. Okay, so it will be circle like this. So it is interior part of circle, so that's why I'm drawing a dotted curve, getting dotting circle. Since it does not contain its boundary, we have a strictly less than. If equality is there, suppose equality is there, then it contains its boundary also, but equality is not there. Okay, so that's why just interior part of circle. So I will show in this way. Just a minute. Yeah, that's it. So this is a circle we have. Okay, so this problem we have solved. So I suggest you to take a screenshot of it, and after that we will stop. Thank you. Bye bye.